Let's go ahead and get started here. Thank you again and welcome to the day 2 of the 2022 Silicon Flatiron Spectrum Conference. Yesterday was a lot of fun. I certainly enjoyed it. We had a great keynote speech from Austin Bonner, some very interesting panel discussions, and the breakout sessions were very interactive. And a lot of ideas came out, and I'm very much looking forward to seeing what the recommendations are coming out of this. And that's the topic for today, is the outbrief on the actionable recommendations. I guess I haven't had enough coffee yet. And then we'll have a final panel to discuss the pros and cons. So first, though, we have another outstanding keynote lined up for people. It's my pleasure to introduce Tom Rondeau, who is the Principal Director for FutureG 5G at the United States Department of Defense, Office of the Undersecretary of Defense for Research and Engineering. So, thank you, Tom.
Good morning, everybody. All right. So Tom Rondeau just joined the Office of the Undersecretary of Defense for Research and Engineering a month ago, taking over the portfolio of 5G. Also, the newly defined role of FutureG, or future generation wireless networks. So, like I said, a month in, so therefore I know everything that's going on in this portfolio. But it is huge, actually. It's exciting work. It's an exciting time here. Let me make you focus on me for a second, not the slides. So I wanted to start off with a couple of remarks, kind of maybe introducing some of the philosophy that I'm bringing into this job here. So for those who, I know a lot of you here, but for those who don't know me, I just came from a little over 6 years at DARPA. So I spent 4 years in the Microsystems Technology Office and 2 in the Strategic Technology Office, building programs all the way from the antenna to the transceivers to the digital processing, edge processing capabilities, to data protection technologies, and then applications that make use of all of those. So kind of taking that holistic perspective of RF to information to security as part of it. Before that, I ran the GNU Radio project, which is an open source software framework for software-defined radio. And while I was doing that, consulting for the government at the same time. So I come to this from both deep roots in the open source world and kind of almost an academic push for new science, new technologies, new concepts, and the ability to spread that through frameworks like GNU Radio, to allow people to explore faster and better. And I don't know how many times Julie has watched me give talks about GNU Radio and me apologizing to him when he was at the FCC, but he would always make that face. No, because I always appreciated how much you guys enjoyed the experimentation that we were trying to enable and create new ways of approaching the spectrum, or what I like to say, programming the electromagnetic spectrum. I also have a deep root in the DoD, in the classified world, so I have this weird dual hat that I have to manage and separate responsibilities there. But what's nice about that, in the background there, is my work has been very clear as far as why I'm doing it. And I think that's maybe what I hope to push in today's, this morning's talk, is spectrum policy. And we talk about incentives and we talk about who's making decisions. I keep coming to the question of why are we making certain decisions? And I have clarity in that because I'm here to support the warfighter, I'm here to support national security. That drives the decisions that I make and the things that I think about. And that clarity helps us make decisions, it helps us push technology forward. So anything that we can do to make our warfighter more survivable and more lethal, which I know is a phrase that not many of you guys understand necessarily if you're not in the DoD, but that actually means a lot to us. But I wanted to start off, I'm going to read from this one for a second because if you're from the DC area, hopefully you've gone and seen our newest presidential memorial, the Eisenhower Memorial. So I walked down there one day and a quote from his inaugural address has always stuck with me. That love of liberty means guarding every resource that makes freedom possible, from the sanctity of our families and the wealth of our soil to the genius of our scientists. And I love the fact that he put the scientist in there because I suddenly feel like he's speaking to me. But I like the holistic, again, that this is the United States coming together to do certain big things. And one of the big things he did, of course, was the National Highway for Defense Act, creating the interstate highway system. And it is interesting that the bill was for defense. And he actually had economics, safety, but also national security in mind when we built the interstate highway system. So again, that's always stuck with me. So the other aspect that I want to convey is a little more frivolous than quoting a president's inaugural address. Because when I talk about the information, or when I talk about the highway system, relating that to information and how the use of information, the use of our networks, our wireless networks, are critical to the next generation of our safety, economics, national security. And so if, who here has seen the movie Sneakers? 1993, one of my favorite movies. Ben Kingsley's character Cosmo talking to Robert Redford's character Martin. The world isn't run by weapons anymore, or energy, or money. It's run by little ones and zeros, little bits of data. It's all just electrons. So I really like that because that was 1993. And so many decades later, that is probably more true than it's ever been. And that's, again, what helps drive me is those are the things that are going to keep us safe and keep us successful as a country. So that's kind of the background, how I think about stuff. And so let me go into the meat of this to give you some sense of how we're approaching solving some of these issues for the United States. A little background on the 5G project. I was at DARPA at the time when this came out as we're behind, we're losing an edge in the market and national competitiveness. And Congress identified that and came to the DoD and said, can you help us? And we pushed through and help make us more economically competitive, and again, also for our national security. So the DoD was given a big responsibility of a lot of money to execute on how we impact the 5G in the FutureG world. So we created the program that I'll talk about a couple of years ago, pushing forward on how do we incentivize work in 5G, and how do we incentivize the United States to become more competitive there. So this involves a number of different objectives laid out to help with this. So we talk about our Accelerate portfolio, the 5G prototyping experimentation. You've probably heard a lot about this. This at the time, I think still is maybe the single largest public investment in 5G technology by putting over $600 million into rolling out 5G installations across a dozen bases around the United States, creating test beds and infrastructure for 5G systems that we can then use for experiments and for pushing new applications. Specifically new warfighting applications, but we always had a mind of the dual use concepts of those applications. What in those, what's new about 5G that enables us to create an application that is both suitable for the warfighter and for our DoD enterprise, but also for that can have shades of or be moved into commercial markets, commercial applications in the future. How can we work together with industry to make that happen? We'll talk a little bit more about some of those in a second. Secure 5G. That is one of the most interesting things, one of the biggest challenges that we face. We understand the value of using dual use technologies for the government at this point, for the DoD. The way that I looked at it, I gave this talk when, it was 4 years ago now, when Steve Walker was the director of DARPA and he was sitting in the front row. And I went over at that point, I guess it was 2019. At that point, we estimated that R&D around the world was between $70 and $100 billion a year in 5G research. So I looked at Steve and I said, even if we're at the minimum of $70 billion, that's 20 times DARPA's budget. So will you give me all of DARPA's budget to give us to help start this? And he blanched and said no. But the point being, that amount of money is that the commercial world is pouring into this is significant. Why? Because it's that hard. It's a really difficult problem making a reliable wireless network that works as seamlessly as it does for us today. Our investments in the DoD will never compare to that. So how do we make use of that? How do we make us successful by being able to use that? The flip side of that is, of course, We have issues of supply chain assurance, cybersecurity issues, just security issues in general. So if we're going to buy something off the shelf, how do we know that the information, our little ones and zeros, are protected as they're transiting these networks and as they're using this equipment? So securing 5G, or what we call operating through 5G infrastructure, is a critical part of what this portfolio is doing. Then we talk about innovate beyond 5G. That one's kind of being rebranded now as the FutureG portfolio. This is all of the new research investments that we want to make, the things that aren't necessarily part of the standard, or maybe are nascent parts of the standard today in 5G, as we're pushing towards advanced 5G into 6G and beyond. So we're having a number of research projects that we're investing in to try to get that going. And then really importantly, I keep talking about making the US competitive, securing the US. This doesn't happen without our partners and allies. It doesn't happen without an interagency view of the world. So we're very dedicated to working internationally. I have an entire team that works developing international agreements with allied and partner countries. And we're pursuing those pretty aggressively with a lot of the ones that make a lot of the hardware that we need to use and we need to understand and secure. So that's kind of the overview of the portfolio of what we've been doing in the 5G world. So I'm going to go into a little bit of depth on a little bit more depth on each of these. So kind of going over, this is just another visitation of what I just talked about. But let me dive into a few of these points here that are important. One of the things that we're looking at here, and this of course is Spectrum Conference, so of course RF technologies for accessing spectrum are part of our portfolio. How do we make things that are able to use more of the spectrum, the low, mid, and high band as we call it? How do we advance technologies in the millimeter wave regime? There's a lot of hope for millimeter wave, and so far a lot of disappointment that's been behind some of that hope. So how do we actually create the new technologies that are going to make the amount of capacity, the amount of resources in the millimeter wave bands useful for us in the DoD? And again, how do we then push that as far as commercial success? So there's some really interesting stuff that we've got to study there. Spectrum sharing is, of course, continues to be a big part of the portfolio. We're studying that at some of the bases, some of the installations, Hill Air Force Base specifically. You've probably heard some of the results of that already from the radar studies that were done at Hill. Some of them were done at Hill Air Force Base with military aircraft. Majors Field is another one down in Texas for some of the other aircraft. So we've been looking at that. Open architectures and virtualization. This is important to me because I think that breaking open some of these architectures is how we create a new space for innovation, but also security. And I talk about open, transparent, and secure technologies, which sound like they're competing objectives, unless you kind of go through the process of understanding what security really means and how we actually analyze and understand what's happening inside of these boxes, inside of these networks and devices. The more we can understand, the more we can monitor that. But then how do you actually balance that with things like data privacy? So those are kind of competing objectives, and I think there's some interesting technology that we're looking at to go after those. Virtualization, though, as part of that, this is where we go, well, what is the US specifically good at? What are the things, we've offloaded a lot of our technology, our manufacturing technologies. Other countries have been doing them well, better. We've offloaded a lot to that. Obviously, if we've been following the Chips for Science Act, we're trying to pull a lot of the manufacturing, the microelectronics back here. But one thing that we're really good at is software and services in this country. So virtualization of a lot of these technologies into software is a benefit to how we can really make an impact and how we can manage this technology space. So that's what one of the things we're going to be pushing really hard on. I talked a lot about the security aspects of it, this operate through, so if you look at it from the sense of we're overseas, we're doing activities over there, how do we actually talk back to the enterprise and how do we manage that space? What is if you're familiar with the PACE plan, the primary alternative contingency and emergency communications, how does 5G or how do these commercial wireless networks play into that plan for us to make sure that we have robust, reliable communications back to decision makers? But in this one, I want to point out to the security aspect of this one. This one is, to me, one of the harder discussions to have because people say we need to secure 5G. How are you going to secure 5G? And unfortunately, that is the question at hand, but it's the wrong question because if you really go down into it, you can never secure something. You can make things more secure, but there's always the possibility for vulnerabilities to be discovered, attacks to be realized and mitigated. But also, when you say security, what part of security are you talking about? It's a huge aspect from cyber to supply chain to the RF threat attack surfaces. So being disrupted, defeated. Why am I blanking on the 5 Ds that we talk about? Deny, disrupt, defeat, degrade. Those types of activities that we like to do in the electronic warfare world. How do we make sure that we're protecting against those in a commercial technologies where the commercial world doesn't really have to think about things? Mathematically, interference and jamming are fairly similar. In practice, they're quite different. When you have somebody specifically trying to jam you, it's a different world than interference. So how do we actually deal with all of those as part of our security aspect? And then the other word on here that I think is important is zero trust. That is about the most buzzy buzzword that I think I'll probably say today, I hope. However, I do believe in it. I think that there is a path forward for zero trust architectures to be implemented, not bought, right? This isn't a product that you install and you make your system zero trust compliant. This is a process and a set of protocols that we can put into place. And we're working very closely with the DoD's Chief Information Officer or Chief Information Office, the CIO, to work on their zero trust architecture and hoping to use our experimentation platforms to roll out zero trust architectures and study how they actually work and how they behave in the real world. So I think that's an exciting one that we can really make a difference on. Talked about our international and interagency. So standards and working with the standards bodies. This one I'm actually going to put out there. I'm not going to go into too much detail. This one I think I need help on. I want to hear from you later throughout the day, possibly, or even in our Q&A, how the DoD should engage in the standards bodies. I have my own thoughts and opinions on this, but I really think this is an important one for how do we incentivize US to take back key leadership roles in these standard bodies without being too heavy-handed of, as I like to come in, I'm the government, I'm here to help. But how can we actually help in the right ways and there's a lot of nuance to that. So I'm going to stop just listing off items on this chart, but again, trying to give you the sense that there's a holistic set of activities that are going on through the 5G work that we're doing. And as we're executing, you can see here again, kind of grouping those into those different those bins there. We've been working for a couple of years now to get things started. Most of our work is now on contract and rolling and executing. And you can see here we've got a fairly large outlook on how things are going to execute and some of these projects are going to execute. We are working very closely with the DoD CIO's office, where a lot of this work is actually going to transition to them over the next couple of years. So they're going to take ownership of a lot of these platforms and be able to work with them. So we're just kind of setting up the early stage of research and work to make all that happen. But we've got some exciting work that's executing here. And I'm going to talk a little bit about that last line in a couple of slides. So this one, I cut this one down a little bit, and it's still this much of an eye candy chart. But this one is one of the more exciting ones that I think we can talk about today that I think will hopefully help you get a sense of what we're doing in the portfolio. This is probably the one that's made the most amount of press. This is that investment of money into building 5G infrastructure across a whole lot of different bases. And where'd Keith go? Point out Keith there for helping really kick this off originally. One of the masterminds behind a lot of the work that was done to start here. I think it was those the 4 in the tranche 1, we call it, the gray boxes there. So I want to give Keith credit for all the work that went into that. So each one of these was designed for a couple of reasons. Geographically across the United States, across the services. So we have all of the services represented in some way in these installations, but also with specific use cases that we were trying to push forward. So you have Naval Base Coronado and Marine Corps Logistics Base Albany, Georgia. Smart warehousing logistics. How do we make sure that our logistics supply and resupply chains are prepped for any DoD activity? Anytime we're called into action, how do we make sure that we're ready for that? Logistics is about as boring as you can get when talking about military strategy, but it's also the thing that wins wars. So this is critically important for us to get right, and how do we actually manage these systems? Because what I'm envisioning here is, imagine we have activities happening in the Indo-PACOM, the Pacific area of the world. We have what we call PAC Fleet, right? The Pacific Fleet. How do we make sure PAC Fleet is successful? Those ships are massive. I was talking the other night about some of our work on different Navy ships, and for those, I know there's some folks from the Navy here today. One of the running monikers that I picked up when I spent some time doing some research on ships is, if you've been on one Navy ship, you've been on exactly one Navy ship. Every one of them is different. The infrastructure is different. The build out is different. So managing the assets, managing the naval officers and the crew that's on those ships, making sure that they're supplied with food and resources and weapons is a very, very hard task. We actually do it really well. We could do it a lot better. And that's kind of what we're trying to enable here out of Coronado, is how do you get those resupply ships tied into the entire, the enterprise infrastructure, so that as we're coming back into the Hawaii region, we're already prepared to resupply them with what they need and do that more accurately and more successfully. So things like that are exciting. One of the other aspects that we keep running into is, why 5G? You look at some of these things and you look, okay, well, it's wireless, it's transport. A lot of people just think about this as transport. Why 5G? What's exciting about it? So we were looking at, how do you stress 5G? How do you take all of those advantages of 5G and put them into practice? So I like to talk about it, you can look at 5G as much more bandwidth, higher data rates than we've ever seen before, okay? Or it's lower latency, or it's more connectivity and density of the devices, or it's that local edge compute model, or it's the network slicing. All those things individually have been done before. And there's different variations on those themes that you could pick up a technology and implement them. What 5G is to me is all those together. And it's a standard that allows us to roll that out as a working system that doesn't have to be duct taped and baling wired together to make work in the field. So that's where something like the AR/VR, that's why we were pushing that one early, was because that does start to get to issues of when you need both the high bandwidth and the low latency to do an AR system for an operational training environment where you're in a room like this. How do you take this room and turn it into a beachhead that we might actually have to go up and storm? The scale of that is hard to replicate around the United States. How can we use these kind of augmented reality systems to create that world for us? That also drives things like local edge compute, because you don't have time to go back to the cloud for a lot of this stuff. So that was going to push the 5G-ness of everything. The challenge, though, that we're having there, I'll say, is where do we get the AR glasses from? I don't know if you've been tracking that, but that's a promise that's still yet to be delivered, I think, commercially. So we're still excited about this. I think it's still a really good challenge and a really good technology space. But where we're going to get those AR, VR, this is a kind of a multi-dimensional problem for us, because it's supply chain, but not in the normal sense of some of the weaknesses of some of our supply chains, like the chips, the semiconductors the past year, but things that seem to have been promised for years and are still always seem like they're another year off. So we're keeping an eye on that, but I think the promise of that is still great. Let me talk here a little bit about which one? Let me talk about Nellis Air Force Base. This one is exciting for a number of reasons. The main one is the again, back to my quote from Sneakers, that information is the key to success here. We have one of the most impressive sensor platforms in the world, and it's called the F-35. That thing pulls out so much data from its environment on every sortie that we don't know what to do with it. So how do you make sure that every time your F-35 2-4 ship comes back into and lands, how do we take that information that it's learned? How do we craft that into new understanding of the operational environment and turn that back around? And for the next sortie, we have a more successful approach to managing whatever threats are out there, electronic targets, radar systems, et cetera. Doing that again stresses the 5G-ness of this technology. That very high bandwidth. We have, and I won't say the actual word, but we have many, many, many gigabytes of data to offload from that system as quickly as possible. We have a timeliness to some of that data that has to get to our data analysts and our algorithms that are running on that. So leveraging the bandwidth, the latency, but also that MEC, that multi-access edge compute system to do that initial triage, to extract the data, to push that to the data labs. That's, again, part of that whole 5G fabric that when you bring those together become exciting. Camp Pendleton's another one that I'm really positive on. If you've been following what's happening in the DoD, the General Berger, the Marine Corps Commandant, has talked about this Expeditionary Advanced Base Operations, EABO. And this is Marines hopping islands, hopping locations around the world, never being targetable, and just causing a little bit of stress to whatever we're trying to accomplish out there. Well, how do you do that unless you have the ability to ramp up your comms, ramp up your mobile-based defense systems, your sensor and perception of the world around you? That can often take us days. We don't have days. We have minutes to set that up. So that again is going to stress that 5G-ness of a highly reliable, multiple connected devices, sensor devices that are all communicating and using that spectrum. It's also going to stress spectrum policy, because how do you use this to hide what you're doing, to camouflage where you are, to blend in with your environment, and to avoid that targetability that RF can provide for us. So we're studying some different concepts at Camp Pendleton to make sure that the Marines are safe and survivable when they go and deploy in the future. So what I'm trying to do here is paint some pictures of why some of these experiments were chosen and what they're going to do for us operationally. Hopefully, if you're not steeped in the DoD world, some of these have at least shown shades of capabilities from a commercial market perspective. So how do we, as the vanguard of funding these types of research activities, lead the way for technologies that are going to be successful commercially tomorrow? That's kind of the balance that we've been trying to create here. Obviously very defense and DoD focused, but we're working with commercial industry. We have all the mobile network operators in the US working with us. We're working with a lot of the vendors provided to do all this. So we're incentivizing them to get started on some of those next generation applications today. So that's the Accelerate, or our base prototype and experimentation portfolio. We also have, as I said, this idea of operate through and this security. And so when you look at DoD operations around the world, you kind of bucket them into three bins: overt, clandestine, and covert operations. Obviously, I'm not going to talk about those latter two, but you know that they are roles that the DoD plays. And how do we make sure, again, that those are successful in doing the jobs that they need to do, survivable, getting the information, getting the activities that are required to make us successful out there? How do we communicate with them safely and securely? And again, we go back to that PACE plan, that primary alternative, contingency and emergency. Everybody goes out with a PACE plan, and most of the time, we never hear from them until they come back. How do we actually create a world where we have more rapid communications and understanding what's happening in the field? But from an overt perspective, that's the easy one to, we've got bases in, all over the world: Korea, Okinawa, a lot of places in Europe. Everybody knows we're there. How do we make sure that we're securely using those systems and managing the traffic that comes back from them as we're transiting the world of a 5G infrastructure. And one thing you probably know is Huawei is about 35-ish% of the RAN, the radio access network market. So if you're moving around the world from any one of these locations, and if you've seen the Belt and Road Initiative map laydown of where those installations are going around the world, there's a high likelihood that we're transiting something that we know we can't trust. So how do we put trusted capabilities onto our networks to enable that movement of capabilities back to the enterprise and back to decision makers? So a lot of work being done here. Part of this is that black box issue that we have of commercial technology. We don't necessarily know what's happening inside of it. We don't have necessarily eyes on it. So how do we actually, again, trust those systems and create those capabilities? How do we deploy our own private networks? But those private networks are great for internal communications. How do you actually push them back to the enterprise and all of that? Really difficult challenges in this space. I think this is probably the most difficult part of the portfolio that we have. And then we've got the innovate beyond 5G. So this one, we're going to continue to evolve in what we care about and what things we can push. These technologies up in that blue box are some of our leading research efforts that we have going on today that are executing. We should probably have results on it over the next half a year to a year for different projects that we have. But you can see, if you've been following the 5G world, and if you're in this audience, I don't think any of these are probably surprises to you. But just want to make sure that you know that we are tracking a lot of them. Beamforming and this multiple input, multiple output, terrestrial and non-terrestrial networks. So NTN, non-terrestrial networks, is becoming a key component of future generation technologies. We want to make sure that we're on the forefront of that, and again, pushing that, because that is that is part of that multiple approach to getting data back and moving data around the world. You've got your 5G bubbles, but how do you actually get that again back to the enterprise? So lots of things happening here, and lots of things that are working directly with the services to be laid down onto the onto experimentation that we can have with the services. A little teaser: we just came back from working down at Virginia Beach with the SEALs, SEAL Team 18, which, if you've never heard of that, it's because they're fairly new. It's one of the old support teams that's just been rebranded as an official team, Team 18. Actually doing some activities with the Stiletto, which is a really cool Navy platform. If you've never seen it, it's a pretty. I thought it was exciting because I did an operation, or not an operation, an experiment with it a couple years ago, and I went to the Navy. The Navy. There's a Commodore sitting there, 1 star. And I go to him, I was like, yeah, so I need to use your boat, but we got to put an antenna on there. Like, what's the authority that we're going to need to go through? And if you've ever tried to put an antenna on a ship before, it's about a 4 to 5 year process. And the guy was like, wherever you want. He's like, yeah, you want to drill a hole in the boat? Yeah, and just run your cables wherever. And I was like, it was the most amazing thing I've ever heard the Navy say. But it's a cool ship because it allows you to do that kind of experimentation. And so we've actually been doing mobile 5G on a boat out at sea using the Stiletto. So some cool results to be brought back from there. So I'm going to finish up here in the next couple of minutes, just talking about some of these specific activities that we're creating in this open space, because I really do believe that creating an open technology base for innovation and to execute new ideas on is important. When you think about a lot of the promises of 5G and a lot of the application spaces that people have been talking about, how do we actually lay those down on real world working capabilities, breaking these things open and allowing us to have that exploration. Think about the 80s and 90s innovation space for the internet. A lot of that was based on those open technologies back then. I'd love to be able to recreate that kind of energy, that kind of work that we can do here with a wireless networking world. So big push on open interfaces, working with Open RAN or ORAN. My team, Amanda Toman, who's my deputy principal director, has been the acting director for the last year. She was just out here in Boulder last week with Cable Labs, showing off the the results and and congratulating the finalists of the phase 1 of our 5G challenge, which was all about studying open interfaces and connecting different vendor devices together and showing that if you define the interfaces, you can actually build a system well. We're now going to be working towards phase 2 of that challenge, and I think we've got some exciting stuff planned for how that's going to play into this. So trying to build out that ORAN, working with them, but also it's not just open interfaces and it's not just open architectures. We're covered in open architectures in the DoD these days. I don't care for open architectures unless you at least have a reference implementation to go along with it. Somebody's got to show you how it can be done and how you can actually integrate these things together. So when DARPA and R&E collaborated early on in kind of defining what we wanted to do with 5G, a couple of the things that we defined were projects to create open source technologies, open source software technologies that could be used to create this innovation space. So open programmable secure, that one was looking at the market of, again, these black boxes and a lot of it, the domination of Huawei in that space, and trying to say, if we can open source this, much like Linux did for the internet, let's open source the software stack that goes on top of the hardware, and that gives us more insight, more ability to observe what's happening in there, and we can create better technologies, we can create better, more secure systems on there. So again, open, programmable, secure, all three of those together are important words for this project. So we're studying things like how do you make sure that network slices are secure and don't leak information. They're studying how IoT devices, Internet of Things, little sensors, right? These are very battery limited systems, which means that most of the time, the first thing that you're gonna drop is authentication and security because that takes energy to do. So we're studying new ways of approaching that to minimize the energy consumption, but also making them secure. What we didn't do in OPS is create a open source 5G network core. We thought about it until I got in touch with my friends at the Linux Foundation, and they've already been working on that 5G blueprint. So they've already been investing, the commercial world has already been investing in creating that open source network core. So we now have DARPA, got to get rid of the we, I'm no longer at DARPA. DARPA has a credo with the Linux Foundation to work together on building out those security overlays on top of the open source core. We also have this multi-ops 5G joint independent testing option, and I'm glad that acronym is written out there because I can never remember what Mojito stands for. But Mojito is a exciting possibility for this experimentation that I talk about. This is to put these open source cores in multiple installations of those bases that I showed you on that map overlay of the United States. If we can actually connect all these together through these cores, have multiple cores, but all actually jointly network together, we can start scaling our experiments that can represent real data, real traffic, and real problems in the real world. Right now, we have a lot of islands of experimentation, and they're all useful in their own right, but the scaling problem of a real wireless network needs to happen for us to really get our arms around it. And so that's what we're trying to push with Mojito, is how do we actually connect all these together and create networks at scale that we can use to study. So that's the rundown of the portfolio of what we're doing in 5G. I think the lessons learned, I think we now know this is inevitable. We have to figure out how to use this for the DoD. It's exciting that we've been able to push the technology and incentivize the commercial companies to, and pay them to do exciting work of application and technology development that the commercial world maybe was ready for, but was envisioning. So we're helping bridge that gap into some exciting new capabilities. And I think you're going to see over the next year, as we're really pushing with a lot of the now existing, building up these test beds and executing. So I hope, Keith, next year I can come here and show you a lot of results of what's been happening in these things, not just the vision of what can happen. And then I think we can start rolling from there. And with that, I'll close it out and take some questions.
Okay. Why is there a role?
Shove him back. Mike's coming up to you.
Hi, you mentioned it's kind of a balancing, well, not a balancing act. You're obviously focused on defense purposes in your research, but that you kind of keep an eye towards future commercial uses. Are you able to like elaborate on like what steps you take throughout the process and kind of keeping those future uses in mind and looking forward?
Yeah, no, that's a great question. Thank you. The kind of philosophy behind this is if we are to be able to successfully utilize commercial technologies securely, that doesn't matter unless there is a robust market for those technologies to exist for us to pull from. So then in practicality, we're using the other transactions authority for contracting with commercial entities. So instead of using the Federal Acquisition Regulation rules for most DoD contracts, we're actually building agreements with companies. They're not contracts, they're agreements where we can actually jointly invest and jointly work on technologies that are important to both of us. So that again, it's not us going and saying, this is important, we're gonna pay you $1 billion and go develop this one-off just for our purposes. It's what are the things that are important to both of us so that we can understand what's gonna help them make that commercially successful and make sure that there is that sustainable supply chain of technology that we can continue to pull from.
Hi, Anton Monk with Viasat. Thanks for the presentation. I actually think there's a perfect intersection with what you presented from the OUSD standpoint and Spectrum. So we're participating in a number of the DoD OUSD projects. I would say one of the biggest concerns is not actually the 5G technology, it's spectrum access. And I would say the lack of a clear model or plan so that we've had to go and say, okay, here's CBRS, we'll use CBRS, that's available to us. Or there's some federal priority millimeter wave bands. But other than that, you have to go and partner with the MNOs to find something. So there isn't really a clear path for testing in the US. Outside, who knows what's gonna happen? I'm just interested in your thoughts on that.
Yeah, that is a big challenge for us. We have agreements. We've been working with the MNOs, the big three in the US. We're also working with CBRS, Spectrum, specific down in Albany. They're using CBRS down there. But you're absolutely right. Even CBRS, we're just doing the generalized access model and only getting some megahertz of spectrum here and there. With the MNOs, we come to the table. It's like that scene in Empire Strikes Back. The steel keeps getting worse every day. They promise access to the spectrum, and then when we go and want to execute on that, all of a sudden we're told, "Oh, hold on." So yes, that definitely is a vexing challenge, and frankly, one that I have been disappointed in, not wanting to do more spectrum policy in my current work, and realizing that that's going to be a huge part of my job, is to try to figure that out with those folks. We are working with them. We've been developing better relations with them to allow us to have more access to the spectrum specific to the base installations. So the fact that we do have these test beds on military bases where we do have some amount of control over the spectrum and kind of geographically isolated in some senses helps us with that question. But it does vex us with kind of every time we want to try to run an experiment that we've got to work through this. I will say that another aspect of this that we're studying right now is it was perceived as a real benefit to go to these private wireless networks to establish them so that we could actually have some kind of control, ownership, and management of that stuff. But it didn't solve the spectrum problem. And we may have just offloaded the fact that we used to pay $50,000 for a radio, and now we pay $500 for a radio, but we have to pay a license fee every time we access that network. So the trade space there is also kind of, from an economics perspective, is also kind of vexing. We've got to figure that out. The only thing I can say is what we're doing right there is continuing working with the MNOs and trying to build better approaches so that we can establish a cadence for being able to use the spectrum more effectively. The challenge that I have there is that doesn't scale. It doesn't scale beyond the base, and how do we actually make that work? That's a really, really tough challenge. we got one more over there. Keith, how much time we got?
Hello, Mark Walker. I'm from Cable Labs. You know, on the spectrum access challenge you just mentioned, how do you think about 5G and RU, sort of new radio unlicensed technologies? Do those fit into your portfolio or your thinking at all?
They should. So we definitely are tracking that. We are definitely thinking about those types of things. We actually don't have anything active right now. I think that's all I'll say on that. As we're pushing to the future with more of the O-RAN technologies and more of the new approaches that we have, but currently we're just working with the licensed spectrum. I think we had one more down here. Oh, sorry. I was.
Preston Padden, I want to thank you for your excellent presentation. I was particularly excited to hear that DARPA has a CRADA with the Linux Foundation on the open 5G core. I wasn't aware of that. I want to ask you, and this might be outside your remit, about receiver standards. As demand for wireless services continues to explode, we're not going to have enough spectrum to allow sloppy receivers to continue to preclude use of adjacent spectrum. Now, the 3G, the most ubiquitous radios in the world are cell phones, and the 3GPP standard includes something called adjacent signal rejection that requires your cell phone to not accept interference from adjacent signals. And right now, there are several prominent examples in the US of sloppy receivers precluding the use of adjacent spectrum. You've got the aviation community with Verizon and
Just for time's
Yeah,
sake,
yeah.
I get your.
Are you doing any work on receiver standards? Because right now DoD is using political muscle to prevent poor legato from activating its spectrum. And you smile, but honestly—
Well, you said poor legato.
Sir,
That's all it is.
Sir, I think it's shameful, and I hope that you would be doing work on receiver standards.
So that, I think you're right, is outside of my area. That's where DoD CIO would probably have more of a specific response to. What I'm interested in are technologies that help coexistence and the ability to operate adjacent co-channel. Lots of things with your interference rejection, lots of better filtering technologies, adaptive filtering technologies. I don't have enough information right now to give you any sense of where I stand on receiver specifications directly. Just that those technologies are going to be helpful for us as we're going into these congested and contested environments anyways, and how they help in the commercial sector. That's where we're, from an R&E perspective, pushing the technology and the research.
Okay, I think we're out of time here. Thank you very much, Tom.